4 is on inequalities in triangles. So the triangle inequality theorem, do you guys remember what that says? Basically, if you have a really long side, like 20, and if I had another side that was like 12, this third side has to be greater than what number? Has to be bigger than 8. Yeah, do you guys remember that? Because if it was just plain 8, then these two pieces would be flat along the 20. So we'd have our 12, and we'd have our 8 just kind of flat, and it wouldn't be pushing up to be a triangle. Okay, so we need it to be these two sides, 12 and 8, to be, need to add to be greater than that third side. Okay, so the third side would have to be smaller than 20. Okay, so that's what the triangle inequality theorem says. It says the sum of any two sides of a triangle is greater than the length of the third side. Okay, so if I have 3 side measurements, and I had 4 and I had 5, what are the range of things that are possible for this third side? It couldn't be bigger than what number, or equal to what number? 9. It has to be definitely smaller than 9. Does that make sense? But what if this 5 was our big side? What if that was the largest side? Then it has to be bigger than 1. Does that make sense? Because if it was like 2, that would be okay. 2 plus 4 is greater than the 5. If it was 1.1, that would still be okay. 1.1 added to 4 is still bigger than 5. Do you guys understand what I'm saying? So it would kind of push it up a little bit to make that triangle. So it says, can a triangle have sides with the given lengths? So can I have a 2 inches, 3 inches, and 6 inch? No. Imagine having the 6 inches on the bottom. If I have one that's 2 and I have one that's 3, it's not going to be long enough to make them meet to create that triangle. They're not going to be touching, right? So this is no. How about 1 centimeter, 15 and 15? Yes, that works. So imagine having a really short side and then we have 2 really, really long sides, right? That would work. All right, 8, 10, and 19. No. So imagine the 19 on the bottom, 8 and 10 aren't long enough to make a triangle. 11, 12, and 15. Yeah, it works. All right. So the lengths of 2 sides of a triangle are given. Describe the lengths possible for the third side. So there's a real quick way of doing this. The quick way is add the 2 numbers together and then subtract the 2 numbers. Okay, so if I add the 2 numbers, I get 20. If I subtract the 2 numbers, I get what? 4. Okay, so that third side, which I'll call x, is between 4 and 20. Okay? Do you guys understand why that's true? So imagine the 8 and the 10, or 8 and 12 are our short sides. That means that longest side has to be shorter than what number? Shorter than 20. Okay, but if 8 and 10 aren't our short sides, if 12 is the longest side, I would need 8, and I would need at least what number? I need bigger than 4. Does that make sense? Do you guys get why this is true? All right, so the next one. So 5 and 16. What's our side between? 11 and 21. Perfect. You subtract them and you add them. All right, the next one. 18 and 23. 5 and mental math. 41. Good. All right, this next one. What do we have? 2.6 and 13. Perfect. All right, so the theorem comparing angles and side lengths, I've also kind of mentioned this to you before. If you have a small angle, it's across from the smallest side. If you have the medium, it's across from the medium side. And if you have the large angle, it's across from the large side. Okay, so that's what that's saying there. Okay, and if you think about something that has a really obtuse angle, I think that makes sense. If you think about the triangle, isn't this going to be the longest side across from this biggest angle? So it says list the angles of each triangle in order from smallest to largest. So smallest side was KL. Well, what's across from it? Angle M. So we're going to start with angle M. That's going to be the smallest. Then what are we going to have? Angle L. And then last one, angle K. Yep. All right, so you can write angle ML and then K. All right, so then what else do we have? So the next one, this across from I, that has to be the longest, right? Why does that have to be the longest in this triangle? It's the hypotenuse, right? Okay, so we have, I'm going to lose my voice again. So we have the shortest one is angle G, the medium one is angle H, the longest one is angle, or the largest is angle I. All right, so this X, and this 3X allows you to compare these two other sides. The 3X is definitely longer than X, right? It's 3 times longer. So E is the longest, or the largest angle, so let's put that at the end. So what comes first? What's the shortest, or the smallest angle? Angle D. Then we have angle C, and then we have E. Does it make sense? Do you guys get this? It's pretty easy. This is why this chapter is not really a hard one. All right, so it says list the sides in order from smallest to largest. So now we're doing sides. So we need to find this last angle. So if we add those together, we get 45 plus 75 is 120. So it looks like we're going to have 60 degrees. So for our angles, we had O, and then we had M, and then we had N. So now let's do the sides. So we're going to have side MN, and then we're going to have side ON, and then we're going to have side OM. Okay, 3 sides. Does this make sense? And you can mix it, like you could say NM instead of MN, right? It doesn't matter which way you write the segment. Okay, so these 3 are in order for us. So we have 51, 59, and 70. So let's look how this worked on the last one. Do you guys see how we had angle O, and the side across from it was MN? It uses the 2 letters that aren't included, like with the angle. So it was angle O, so get rid of that. Now it's going to be MN across from it. Do you guys understand what I'm saying? So if I have angle X, what side will be across from it? YZ. Does that make sense? So you could draw the picture if you need to. But we're going to say YZ, and then we have angle Y, so what's across from it? XZ, and then angle Z, XY. Perfect. Oh, I think I have something wrong with this one. I remember this having an error. I think I left off an angle, but let's at least compare a little bit. So let's compare in this triangle, and we'll compare in this triangle. Okay, so if I have 110 and I have 32, I can find that third measurement, which is 38. And then I have 30 and I have 114. So this one's going to be 36. So on the left triangle, so C, D, and B, we had 38, we had 110, and we have 32. So let's write those those sides in order. So we have side, geez, that's loud, CD, and then we have side BD, and then we have side CB. Right? Does it make sense? Let me write it as BC. I usually try to write alphabetical order if possible. Okay, so this next one. So in this other triangle, we had 114, we have 36, and we have 30. So in this triangle, we have BD, we have AB, and then across from 114, we have AD. So the thing I was trying to get to work with this, and I realized it doesn't, is I wanted this last one to be BD, because then I could put all the segments in order. Does that make sense? Because if it was BD, then this other one starts with BD. So then it's like, oh, this one's smaller than this is smaller than this. So now connecting the two triangles together, it's all like that. But there's no way for me to say where BC is. Does BC go on this side or does it go on this side? So that's what I thought I had wrong with that one. So I do have something wrong with that. So if I put like one segment measure, maybe it would help us compare them. All right, so that's it for that one, right?